to prove this one, we will prove by method of contradiction. We'll try. Okay. So first what we do is, suppose the result is false. Method of contradiction. Suppose the result is false. Suppose the result is false. Then that implies then there exist numbers some x comma y comma z such that x is less than y is less than z, and what I assume, suppose the result is false, this result is false, then there exist numbers x comma y comma z such that and either different cases I will take, either f of z is less than f of x is less than f of y, or you can take f of x is less than f of z is less than f of y, or next x y z orders you should not take other than that one, that is f of z is less than f of x is less than f of z is greater than f of z is greater than f of x is greater than f of y, or you can take like this, f of x is greater than f of z is greater than f of y. Yes, sir. Like this. Clear? If x is less than y is less than z. If it is monotonic, strictly monotonic, then the condition is what? When we say that the monotonic, if alpha is less than beta, then f of alpha is less than f of beta, then it is strictly what?
Monotonic.
Increasing.
Increasing function.
Monotonic function. Monotonic. But you can reverse this. Suppose the result is false on this. That's why for x is less than y is less than z, any of all these four things are true. Order of these colleges. Why I have written these four?
Yes. Yes.
Yes. Now what you do is, now you consider the first one. You can take anything. I will consider. I will take this one. That is f of z is less than f of x is less than f of y. F of y. Okay, na? Now,
Yes.
see, f is a continuous. F is continuous on closed y comma z or not? Continuous in y comma z. Okay, the closed interval y comma z if continuous. Okay.
Yes.
Y comma z. So if f is continuous on y comma z, then f of x is strictly between what? F of z and f of y or not?
Yes, sir. F of y and f of z.
F of z. Therefore, f of x strictly between f of z and f of y. F of z and f of y. Right. Now, by intermediate value theorem, by IMVT, there exists some t belongs to open interval some y comma z such that f of t is equal to f of x or not. Intermediate value theorem untunda leda? See, we'll draw the graph. The graph is what? In between what? Y and Z. So this is Y. Our interval is what? YZ. And the function is continuous function. I am taking the increasing function. This is f of y. This one is f of z. Okay, na? See here, f is continuous. F is continuous on y comma z. I consider on y comma z. Therefore, f of x. F is continuous on y comma z. F of x strictly between f of z and f of y or not?
Yes, sir.
Yes. F of x strictly
Yes,
between f of z and f of y. So the f of x will be somewhere over here. So from intermediate value theorem, we know that for this f of x, there will be some t in between yz or not?
Yes, sir.
Yes, sir.
That I have written here. See, by intermediate value theorem, there exists some t belongs to this y comma z such that f of t equal to f of x. Okay, na? F of x.
Yes, sir.
So now, yes, t belongs to. Yeah. Now function is what? 1, 1 or not? F is 1, 1. Okay, na? If it is okay, మన ఏం తీసుకున్నాం, ఇది కాదని తీసుకున్నాం,
will be x, sir.
ఇది కాదని తీసుకున్నాం. F is a 1, 1. Therefore, since f is a 1, 1,
T equal to x.
yes, since f is 1, 1, that implies t must be equal to x or not? అర్థమైందా?
Yes, sir. Yes.
T is equal to x, but t belongs to y comma z. Therefore, x must be belongs to, since
Y comma Z.
yeah, కానీ కాదు కదా, t belongs to yz. That implies x must belongs to or element of y comma z. కానీ x element
Our
of y comma z
assumption
అవుతుందా? చూడండి,
No,
x
sir.
element of y comma z కాదు కదా, మనం కన్సిడర్
It
చేసుకుంటాం
is outside that.
outside. That's why why we got the contradiction. Our assumption is wrong.
Yes, sir.
Right? Yes. Therefore, x must be, but x is less than, y is less than z. Therefore, contradiction. Why we got the contradiction? Our assumption is wrong. It's a very good example for contradiction also. Method proof by contradiction. Therefore, contradiction. Therefore, our assumption is wrong. What was our assumption? F of x is not strictly monotone. Kada? Therefore,
Yes.
f of x is strictly monotone. So this is the proof.